All right, let's look at this question. We want to find the limit of x plus 2 all over x squared minus x minus 6 as x approaches minus 2. We want to find that limit, and it is a rational function, so we have to make sure that it is simplified. So let's simplify the function first. So this is actually the numerator stays the same, the denominator, you can factor the denominator and becomes x plus 2 and x minus 3, and now we can look at it and say, okay, x plus 2 top and bottom, there are common factors, we can divide. So now we're looking at the limit as x approaches minus 2 of 1 over minus 3, and here we just substitute negative 2 for x. We get negative 2 minus 3 is equal to negative 5, so the answer will be negative 1 over 5. So that is the answer to the question for the limit. Now I also want to show you what's happening on the graph. If this was the function, this x plus 2 all over x squared minus x minus 6, the rational function, if we do a graphic analysis of that, let's see how that's going to show up. Okay, let's go to the graph now. So here's the graph of the function we talked about. Actual equation, the graph is right there. I'm using Desmos, by. So when I graph this function, the rational function, I get this actually is a rational function, and in this case you can see when I do a factor form of this, which I did, which is in the blue graph. By the way, the blue graph and the red graph, they are exactly the same. So if I unclick that, notice that the red graph shows up because they're the same functions, just that in a factor form. So when we look at the table of values, notice that at minus 2, so look at the factor form, which is right here. This factor form, by looking at it, notice that there are two restricted values. One is x cannot be equal to 3, the other one x cannot be equal to negative 2. Now x equal to positive 3, that is your vertical asymptote. That's where you get the asymptotic graph. One part is in here, the other part is down here, and is actually the x equal to 3, the vertical line, the vertical asymptote. That's the equation of the vertical asymptote, is right in between. That's the first restricted value. The second restricted value is when x equal to negative 2. It says undefined. Well, in this case, it's not an asymptote. It's actually a point of discontinuity, and that is exactly at minus 2. Now if I zoom in, so I'm going to zoom in a little bit, and I'm going to put my cursor right where at x equal to minus 2 is, and I'm going to find that point, and it should give me minus 2, an undefined value. And that is true. It is undefined for that value when x is negative 2. However, limit of that is negative 1 over 5, which is negative 0.2, which is right there. And that's how we are getting the limit. Even though it is undefined, but that doesn't mean that the limit doesn't exist. The limit does exist. It's just that the value of the function is undefined. So be aware of that and make sure that you differentiate between the two. And that's about it. So this is the graph, a representation of that function, and then a little bit of explanation of the limit using the graph.